At Dyson, we design things to work better, to solve a problem. And it can be a painstaking process. We have to consider every aspect of the machine, how it works, how it performs, how it's used. And every step of the way, we test and evaluate to make sure we fully understand the technology that we're developing and to be able to compare ourselves against others. On an upright vacuum cleaner, there are two mechanisms by which the machine picks dust up from the carpet. There's the brush roll that spins round and the bristles agitate the carpet fibres, loosening the dirt. And then the suction in the machine draws the dirt up from the cleaner head up through the cyclone where it spins around and is separated from the air. So on this test rig, we've got the cleaner head sealed down to an AirWatts box, and that allows us to measure the suction power of the machine at the cleaner head, the bit that's doing the work on the floor. And you can see when you compare the suction on the Dyson machine, there's a huge difference. Some cleaner heads have dials, so you have to fiddle around to adjust them for the setting of for the floor surface you're cleaning. But ours we've designed so it automatically adjusts, so it's optimised whether you're cleaning carpets or hard floors. And the way it works is on carpets the sole plate rides up and the bristles penetrate down, so they can then clean the fibres of the carpet and agitate the fibres. On hard floors, the sole plate drops down, creating a close seal to the hard floor. And that means you get really good pickup on hard floor and in crevices. We've designed the cleaner head so it works really well on hard floors, carpets and on crevices. The test is 5 double passes, but pretty much after the second pass, nearly all of the dust in the crevice is gone. In fact, it's even sucked the dust underneath there out from the sides. But you can see there's hardly any of the dust has moved out of the crevice. It's not really picking very much up at all. So in the home, that would mean all that gunge down between your floorboards wouldn't be picked up. It would stay on the floor. So the vacuum cleaner is, if you like, it's an air system, and we don't want any leaks in that system because effectively that saps the suction performance, which means it'll reduce the effectiveness of the machine. And so we spend a lot of time detailing the small seals in here, which seal onto the filter and make sure that all of the air that comes out of the machine passes through the filter. Some others don't bother with that. So this machine is a HEPA filter, but there are no seals at all sealing the filter to the machine, which means the air and the fine dust coming through the cyclone, which isn't very efficient, can bypass the filter media and come straight into the room air, the air that you're breathing. So it says HEPA filter, but you're not getting HEPA filtered air. So we've designed our machine with a ball, and the motor and the filters are all hidden in the ball, but the ball gives us this great manoeuvrability. So when you're trying to go around tables and chairs, with just a flick of a wrist, you can negotiate the bend. So trying to do the same thing with a machine with wheels is much more awkward. I can't steer it with my wrist, I've got to walk around the table to make it go around the corner. So some machines claim to be manoeuvrable, and the geometry of them does allow a little bit of steering. Just using my wrist, and I can only turn it a certain amount. I still need to walk round the table to actually get it round the corner. So obviously when you're cleaning your house, it's not all about cleaning the floors. You want to clean the stairs, you want to clean the air conditioning grill and the architraves. So we design our machines so they have lots of really nice features that make the usability really good. The wand comes away instantly, there are no catches, and the suction transfers automatically, so you can start cleaning straight away with the wand. The hose is long enough so you can get to the top of the staircase, right past the top step. Oops. So when we're designing a vacuum cleaner, we want to make sure it picks up from carpets and hard floors really well, using all the standard test metrics. But we also want to make sure that in the real world, when you're actually in someone's home, the machine performs as well. And one of the really important things we look at is edge pickup. So you can see there's a really pronounced stripe where the debris that was by the wall has been left behind. There. It's cleaned almost right up to the edge. So when we look at the underneath of this machine, for example, it's easy to see why it doesn't pick up along skirting boards very well. On either side of the sole plate, there's an area where the brush bar doesn't extend to, so there are no brushes going around helping pick up the debris. So it gets left behind as you go along the skirting board. We make sure that the brush bar is as wide as we can possibly get it, and the gap here is as narrow as we can make it. And that's why the edge pickup is so good on our machine. As well as designing a machine to perform really well, we have to make sure it's really robust and durable. And to do that, we do a lot of mechanical testing, actuating and bashing and trying to break every single part of the machine to make sure it can withstand the rigours of 10 years of use in someone's home. So it's a bit of a harsh test, but it makes a point. So the polycarbonate material we make our bins out of is so tough it's used for riot shields.